Hello, so today is our last class in which we will be learning binomial theorem. After that, we will be going to the new lesson. So we will start from where we stopped yesterday. In the previous class, we did some questions. Today we are going to continue with that. So the first question I'm going to write here is in the expansion 1 plus x whole power n, coefficients of fifth term, sixth term, seventh term are in arithmetic progression. We have to find what is n equal to. So, as usual, I will take the general term as NCR x power r. Because I have to find fifth term, sixth term, seventh term, r I have to put 4, 5 and 6. Then n, c, r is 4, x power 4. n, c, 5, x power 5. n, c, 6, x power 6. We will take the coefficients, that is NC4, NC5, NC6 are in arithmetic progression. We have a formula. If A, B, C are in arithmetic progression, then 2B will be equal to A plus C. So using that formula, I can write 2 times NC5 equal to NC4 plus NC6. Now I have to simplify this. NC5, n factorial by 5 factorial into n minus 5 factorial. NC4, n factorial by 4 factorial into n minus 4 factorial. NC6, n factorial by 6 factorial into n minus 6 factorial. So everywhere n factorial will cancel. 2 by, I will write 5 factorial as it is, or I will change slightly 5 factorial because I want to cancel 5 factorial. I will write 5 into 4 factorial. N minus 5 factorial, I will write n minus 5 into n minus 6 factorial equal to 1 by 4 factorial. I will keep same. N minus 4 factorial, I will write n minus 4 into n minus 5 into n minus 6 factorial plus 1 by 6 factorial. I will write 6 into 5 into 4 factorial. N minus 6 factorial, I will write same. So that I can cancel 4 factorial everywhere and I can cancel n minus 6 factorial also everywhere. So this I can write as, continuing this, I will write 2 by 5 into n minus 5 equal to 1 by n minus 4 into n minus 5 plus 1 by 6 into 5. Or I can write 2 by 5 into n minus 5 equal to, I'll take common denominator 30 into n minus 4 into n minus 5. So that I can write numerator as 30 plus n minus 4 into n minus 5. Now my work is just to simplify. So I will have 60 into n minus 4 into n minus 5 equal to 150 into n minus 5 plus n minus 4 into n minus 5 whole square. This further I have to simplify. So I will write 60 into n minus 4 into n minus 5. I will take n minus 5 common. So on the right side, I will take n minus 5 common. I will not write like this. After taking n minus 5 common, I have 150 plus n minus 4 into n minus 5. So that both the sides I can cancel n minus 5. Now left is 60 into n minus 4 equal to 150 plus what I have n minus 4 into n minus 5. Now I have to multiply this. 60n minus 240 equal to 150 plus n square minus 9n plus 20, or n square minus 69n 170 plus 240. What I have is this side 170 and this side 240 will come here. So it will become 410. So plus 410 equal to 0. Or when I simplify this, I will be getting n as 7 or 14. You can see the simplification part. Whatever is left, that you can see. On simplifying this, I think somewhere we went wrong. So let me correct that. I'll start doing from here. 2 by 5 into n minus 5 equal to 1 by n minus 4 into n minus 5 plus 1 by 30. This is what I have. So I'll take 2 by 5 into n minus 5 minus 1 by n minus 4 into n minus 5 equal to 1 by 30. I will take denominator 5 into n minus 4 into n minus 5. Numerator will be 2 into n minus 4. And here minus 5 equal to 1 by 30. I can take 5, 6. So 12 into n minus 4 minus 30 equal to n minus 4 into n minus 5. I will simplify on this page only because while copying it is becoming wrong. Well, when I go to the next page, 12n minus 48 minus 30 equal to n square minus 9n plus 20. So n square minus 9 minus 12 minus 21n. Then I have 20 plus 58. Yes, now I'm getting correct. 28, 20 and 78, I'm getting 98 equal to 0. So now I can factorize this. 14 and 7. N minus 14, n minus 7 equal to 0. N is 7 or 40. Yes, this is right. So instead of going to the next page, better we will do it on the Same page. Otherwise, while copying the terms, we may go wrong. Next, we will go to question number 18. SP and SQ are coefficients of x power p and x power q in the expansion 1 plus x whole power p plus q. Then the first option is SP not equal to SQ. Second option is SP equal to Q by P SQ. Third option is SP equal to P by Q SQ. And fourth option is SP equal to SQ. So first we will find coefficients of x power p and x power q. We will take the expansion 1 plus x power p plus q. The power n is p plus q. When I take the general term NCR x power r, I will have coefficient of x power p. That means r has to be p. So coefficient will be n is p plus q, r is p. This is the coefficient of x power p. Similarly, coefficient of x power q, r is q. So I have n is p plus q, the power, r is q. So these are the coefficients. That means, again, let me write carefully. Next page, SP is coefficient of x power p. So p plus q, Cp. SQ is coefficient of x power q. P plus q, Cq. Now we have to relate these two. How SP and SQ are related to each other. P plus Q Cp, I will write P plus Q factorial by P factorial, P plus Q minus P factorial. Whereas P plus Q Cq, I will write P plus Q factorial by Q factorial, P plus Q minus Q factorial. So here P will cancel, here Q will cancel. Then I have P plus Q factorial by P factorial Q factorial. Here I have P plus Q factorial by Q factorial P factorial. Both are same. That means I can go for the option SP equal to SQ. Okay, next we will go to the next question. Actually, this was our second question. Now we can go to third question. The third question is, the term independent of x in 3 by 2x square minus 1 by 3x whole power 9. This you can take as homework. I will do the next one same this time. The term independent of y in y power 1 by 6 minus y power minus 1 by 3 whole power 9. Both the sums are same. So I will do one. You can do the other one. One you can take it as homework. So this is x plus a whole power n. That means x is y power 1 by 6. A is minus y power minus 1 by 3. The power n is 9. The general term formula is TR plus 1 equal to NCR x power n minus r a power r. So in this general term, I will write n as 9, r I don't know, x as y power 1 by 6, power 9 minus r I don't know, a is minus y power minus 1 by 3, whole power r I don't know. Now I will take y separately. That means I will separate all 9cr, y power 9 minus r by 6, then minus 1 power r, and y power minus r by 3. So I can write the general term as 9cr minus 1 power r, y powers at one place. That is 9 minus r by 6 minus r by 3. 9 minus r by 6 minus r by 3. Because I have to have term independent of y. Y should not be there at all. Y should not be there means the power should be 0. So I will make 9 minus r by 6 minus r by 3 equal to 0. Or 9 minus r by 6 equal to r by 3. 3 ones, 3 twos. 9 minus r equal to 2r. 3r equal to 9 or r equal to 3. Because I got r as 3, I will have fourth term, that is 9c, r is 3 minus 1 power 3, r is 3. So minus 9c3, the fourth term, is independent of y. I can simplify this. Minus 9 into 8 into 7 by 6. 3 twos, 3 threes, 2 fours. So minus 84 is the term which is independent of y. Similarly, I will give you some more questions you can take as homework. The fifth question you can take as homework. The term independent, you can try, of x in x minus 3 by x square whole power 18. Sixth question also you can take as homework. The term independent of x in 2x minus 1 by 2x square whole power 12 is. Seventh question, constant term in x minus 1 by x whole power 10 is. Constant term means no x. No x means the term independent of x. So it's the same. This one also you can take as homework. Now I will start with eighth question. The middle term of expansion of 1 plus x whole power 2n is. Because 2n power is an even power, the middle term will be n by 2 plus 1. That is, the power n is 2n by 2 plus 1. That is, tn plus 1 will be the middle term. According to the general term, NCR x power n minus r a power r, because we are finding tn plus 1, the power n is 2n, R we have to put n. X power n is 2n. R is n. A power R is n. Now what is X? What is R? You can take like that. What is X? What is A? Otherwise, you can take the general term as in another formula also. Easy formula. Instead of this difficult one, you can take 1 plus x whole power 2n. Here the power n is 2n. The general term you can take NCR x power r. Because we are finding Tn plus 1, the power n is 2n, r is n, x power r is n. So I can write the middle term of the expansion directly 2n Cn x power n. Or in short, if I want to simplify Tn plus 1 term, 2n Cn. It is 2n Cn x power n. 2n Cn I can write 2n factorial by n factorial into 2n minus n factorial x power n. Or 2n factorial by n factorial x power n. Or 2n into 2n minus 1 into 2n minus 2 into 2n minus 3, like that up to 1 by n factorial whole square. N factorial whole square I can write n into n minus 1 into n minus 2 into n minus 3 up to 1 whole square x power n. Now, from few terms from this, I can take 2 common. So that I have n minus 1, n minus 2 up to 1. The left of terms will be these which are left off. 2n minus 1, 2n minus 3, 2n minus 5 up to 1 will be left off. Down I have n into n minus 1 into n minus 2 up to 1 whole square and then x power n. So I can cancel one of these. And so I have, because I am taking 2 common from each term, I will have 2 power n. I am not taking 2 common only one from one term. I'm taking 2 common here. I'm taking 2 common here. From every alternate terms, I am taking 2 common. So total I will have 2 power n, because the logic behind it is here total I have 2n terms. Total 2n terms. From half of them, half of 2n, that is from n terms, I am taking 2 common. That is why 2 power n. And then I have 2n minus 1, 2n minus 3, 2n minus 5 up to 1. Denominator n factorial x power n. So this I can write as the middle term. I can leave the answer here. So some more questions like this I will give you as homework. You can try. Question number 9 I will give you as homework. The middle term in x plus 1 by x whole power 10 is. Question number 10. Coefficient of middle term in 3x plus 2 whole power 4 is. So till here, I'm giving you as homework. Question number 11, I will do it now. Let me write question number 11. It is saying 1 plus x whole power n is C0 plus C1x plus C2x square up to Cn x power n. And C1 by C0 plus 2 into C2 by C1 plus 3 into C3 by C2, so on up to n into Cn by Cn minus 1 is n into n plus 1 by k. You have to find the value of k. That is this question. So to do this, what I will do is NC1 is n, C0 is 1. 2 into, actually, instead of doing like this, I can make a formula. Easy method, I will tell you, instead of doing each and every one. Let me write this formula separately. If you have NCR by NCR minus 1, we can make a formula. Already I told you, but I'm making and showing it to you again. NCR is n factorial by r factorial into n minus r factorial. NCR minus 1 is n factorial by r minus 1 factorial into n minus r plus 1 factorial. I can cancel n factorial. So I have r minus 1 factorial into n minus r plus 1 factorial by r factorial into n minus r factorial, which I will write as, I'll keep r minus 1 factorial same, but I will expand this because I can write n minus r plus 1. The next term you have to do minus 1. So I will get n minus r factorial. In the denominator, r factorial I will write r into r minus 1 factorial because I can cancel r minus 1 factorial. And then I will write n minus r factorial because I can cancel n minus r factorial. So I am left with n minus r plus 1 by r. So this formula you can remember. Whenever you have NCR by NCR minus 1, you can take n minus r plus 1. You can subtract these two by this r you can write. Why am I telling you this formula? Because we have to simplify many terms here. Like we have C1 by C0 plus 2 into C2 by C1 plus 3 into C3 by C2, so on. We have n into Cn by Cn minus 1 equal to n into n plus 1 by k. So if I use this formula, it will be easy. How will I use this formula? Here, n minus 0, n by 1, this one, plus 2 into n minus 1 by this 2, 3 into n minus 2 by 3, this 3. Like that, n into n and n minus 1 I have to subtract. So n minus n plus 1 by this n equal to n into n plus 1 by k. See how easily I got it. I can cancel 2, 3, n. So I have n plus n minus 1 plus n minus 2, so on, In the end, I have 1 equal to n into n plus 1 by k. So if I write this in the reverse way, I have 1 plus 2 plus 3 up to n minus 2, n minus 1 and n. Right side I will write the same. So this is sum of first n natural numbers. The formula is n into n plus 1 by 2. The other side I have n into n plus 1 by k already given in the question. So when I compare, I can write k's value is 2, which they are asking for. Let us go to question number 12. In question number 12, 1 plus x whole power n is given as c0 plus c1x plus c2x square, so on up to cn x power n. They are asking you what is c0 plus 3 into c1 plus 5 into c2, etc. up to 2n plus 1 into cn equal to. So in order to find this, we have to follow some logic. What is this logic? I will tell you. I will write C0, 3C1, I will take 1C1 and the other one 2C1. Same way 5C2, I will take 1C2 and the remaining 4 into C2. So on it happens. In the end, I will take 1Cn and then left off is 2n into Cn. I will separate it. 1 into Cn I am taking separately, 2n into Cn separately. Why? Because all these terms which I have taken 1, 1, I can make a pair. I can make a group C0, C1, C2 up to Cn. And the remaining, I can take 2 common from them. So when I take 2 common, I will have C1 plus 2 into C2 and so on. In the end, n into Cn. Now, I have a formula for C0 plus C1 plus C2 up to Cn. It is 2 power n. Now, 2 into this C1, I can write as n. 2 into C2, I can write n into n minus 1 by 2. So on. N into Cn, I can write as 1. Now, I will take n common so that I will have 1 plus this will cancel 2. I will have n minus 1. So on. In the end, I will have 1 again. Because everywhere I have taken n common. So this I can modify and write 2n into 1 I can write as n minus 1 C0. N minus 1 I can write n minus 1 C1. Like that, each term I will modify. The last term I will write n minus 1 Cn minus 1. So actually, if you remember the formula, I have the formula NC0 plus NC1 plus NC2 up to NCn as 2 power n. If I have n minus 1 C0 plus n minus 1 C1 plus n minus 1 C2 up to n minus 1 Cn minus 1, it will be 2 power n minus 1. I can use this formula. So now I will have 2 power n plus 2n into 2 power n minus 1, or 2 power n plus n into, when I add these powers, I will get 2 power n. I can pull out 2 power n, then I have n plus 1. So this I can keep as the answer because this I have it in the options. Depending on the options, we have to simplify the answer. Okay, now we can go to question number 13. Question number 13 is saying 1 plus x whole power n is c0 plus c1x plus c2x square, so on, cn x power n. Then you have to find c0 plus c1 by 2 plus c2 by 3 plus cn by n plus 1. The value of this you have to find. So to find the value, we will simplify. C0 we will write 1. C1 we will write n by 2. C2 we will write n into n minus 1 by 2 factorial, but 3 is already there. Lastly, Cn I will write 1 by n plus 1. Now this I can modify and write 1 plus n by 2 plus n into n minus 1 by 3 factorial and so on, 1 by n plus 1. Now what I will do is I will multiply n plus 1 and I will divide n plus 1 to this expansion. Why am I doing this? You will understand later in the next step. So I will distribute this n plus 1, but I will keep 1 by n plus 1 outside. So first term is n plus 1, n plus 1 into n by 2 factorial, n plus 1 into n minus 1 by 3 factorial, so on. The last one will be 1. Now I can modify this and write 1 by n plus 1. This n plus 1 I can write as n plus 1 C1. Here n plus 1 into n by 2 factorial I can write n plus 1 C2. N plus 1 into n minus 1 I can write n plus 1 C3. And finally, the last one I can write, the one which is left off, n plus 1 C n plus 1. So just now I told you one formula. If you remember, I'm writing here NC0 plus NC1 plus NC2 up to NCN is 2 power n. So n plus 1 C0 plus n plus 1 C1 plus n plus 1 C2 up to n plus 1 C n plus 1 will be 2 power n plus 1. But the problem is I don't have n plus 1 C0. I am starting with n plus 1 C1. So if I start with n plus 1 C1 plus n plus 1 C2 up to n plus 1 Cn plus 1, it will be 2 power n plus 1 minus 1, because this is nothing but 1. This is equal to 1. C0 will be 1. So I'm taking it to the other side. That means now my final answer will be 2 power n plus 1 minus 1 by n plus 1. This is there in the option, so I can keep it as it is. I need not simplify this further. So like this, sometimes when a formula is given to you, you can modify it until you get the option. Okay, we will go to question number 14. In question number 14, 1 plus x whole power n is sigma CR x power r. R is from 0 to n. Now you have to find 1 plus C1 by C0 plus 1 plus C2 by C1, so on, 1 plus Cn by Cn minus 1 equal to. This is what you have to find. So just now in one of the problems, I gave you one formula, and that formula is NCR by NCR minus 1. You have to subtract these two, n minus r plus 1 by this r. So the same formula we will use in each term. 1 plus, I will subtract n minus 0 by 1 plus 1 plus n minus 1 I will subtract and I'll write by 2 plus 1 plus n and n minus 1 I will subtract by n, which I can write as 1 plus n plus 2 plus n minus 1 by 2, taking common denominator LCM, n plus 1 by n. So it is 1 plus n plus 1 plus n by 2, so on, 1 plus n by n. In each term, I can take 1 plus n common. 1 plus 1 by 2 plus 1 by 3 up to 1 by n I will have. After taking 1 plus n common, I think there is a mistake in the question. This is not addition. This is multiplication. Otherwise, you will not be getting the answer. There is a mistake in the question itself, so we will correct it. It is multiplication of the terms. We are multiplying all the terms into. So when I multiply in the numerator 1 plus n power n, because I am multiplying it n times. And in denominator I have 1 into 3 into up to n. So it is 1 plus n power n by n factorial. I have seen the options. I was not getting any one of the options. So if I change addition to multiplication, I am getting the option. That is why I have changed the question itself. So sometimes if question is wrong, we have to see. If we are good at guessing, we can guess and correct it. Let's go to question number 15. 1 plus x whole power n is given as C0 plus C1x plus C2x square up to Cn x power n. Now you have to find what is C0 CR plus C1 CR plus 1, so on up to Cn minus R into Cn. Actually, this type of questions we have done in PUs. So it is a long question, but we will try to do it. There is no shortcut method unless and until you by heart this as a formula. So first of all, I will take 1 plus x whole power n. It is C0 plus C1x plus C2x square, so on up to Cn x power n. If I change 1 plus x as x plus 1 whole power n, then what I will have is, I can write the same answer. I can write, because addition is commutative. 1 plus x is same as x plus 1. So I can write same. C0, C1x, C2x square, Cn x power n. Now I will multiply 1 and 2. Both the sides I will multiply. That means I am multiplying 1 plus x whole power n and x plus 1 whole power n. But while multiplying these two, I am taking only coefficients of. Coefficients of what? Like suppose here in the middle we have CR x power r. C0 and CR, if I multiply C0 and CR, I am getting coefficient of x power r. So I am taking just coefficient of x power r, multiplying both the sides and take coefficient of x power r. So on the right side and left side, both. If I take left side, I have 1 plus x whole power n, x plus 1 whole power n. That means 1 plus x whole power n, 1 plus x whole power n. That means 1 plus x whole power 2n. So in this, I have to find coefficient of x power r. So the power n is 2n. The general term is NCR x power r. The power n is 2n. I am finding coefficient of x power r. So on left side, coefficient of x power r is 2NCR. On the right side, what I have? Right hand side, I will be multiplying C0, C1x, C2x square like that up to Cn x power n, and again C0, C1x, C2x square, somewhere in the middle Cr x power r up to Cn x power n. When I multiply, I am taking just coefficient of x power r. That means I will multiply C0 and CR. Then when I multiply C1, I have to take coefficient of x power r. So with what I have to multiply? I have to multiply CR minus 1 x power r minus 1. C1 I have to multiply with CR minus 1. C2 I have to multiply with CR minus 2. Like that, Cn, the last term which I have in the question, Cn I have to multiply with Cn minus r. Am I clear? C0 I am multiplying with Cr. C1 I am multiplying with Cr minus 1. Like that I will multiply. So Cn I will multiply with Cr minus n. Like that. In this manner, if I keep the second one same. But if when I'm multiplying, what I'm getting, you see, C0, CR, it is matching with the question. But C1, CR plus 1 is not matching with the question. Because when I multiply C1, okay, I will write here. C0 and CR x power r. I have coefficient of x power r. Then C1x, I have to take CR minus 1 x power r minus 1. But it is not matching with this. Okay, that will come under different question. So what we have to do is we have to change this. This expansion we have to change as per the formula. What I will have C0 x power n, C1 x power n minus 1, C2 x power n minus 2, so on, CR x power n minus r, then finally Cn x power n minus n 0. So now the question will be different. That's why we have to do as per what is given in the question. We can do whatever we want, but it depends upon the question also. So I will tell you how to do it. They gave us in the question number 15, what is needed that we have to take in order to get that. So 1 plus x whole power n is given as C0 plus C1x plus C2x square until Cn x power n. They are asking us C0 CR, C1 CR plus 1, so on up to Cn minus r Cn. What is the value? So in the beginning, when I told you how to write this, I wrote 1 plus x whole power n C0 C1x plus C2x square up to Cn x power n. If I change it to x plus 1 whole power n, I told you I can keep the same thing, but I will not keep the same thing because I need to get what is there in the question. I will write C0 x power n, C1 x power n minus 1, C2 x power n minus 2, in the middle CR x power n minus r, and finally Cn. Now I will multiply equation 1 and equation 2. So left hand side, I will be multiplying 1 plus x whole power n, 1 plus x whole power n, because they are same. 1 plus x whole power 2n. And I have to take coefficient of what? So that I have to observe. You can't take whatever we like, as you have seen. So if you multiply C0 and CR, C0, CR. So C0 CR x power n minus r. Similarly, if you multiply C1x and CR plus 1 x power n minus r minus 1. What you are getting? Coefficient of x power n minus r only. So here we are getting a common thing. So we have to find coefficient of x power n minus r. Left side and right side. Right side is very easy. I need not work at all for right side. Right hand side, coefficient of x power n minus r I will get by multiplying C0 CR. Then C1 CR plus 1. Similarly, if you take C2x square and CR plus 2 x power n minus r minus 2, I will get coefficient of x power n minus r. So multiply C2 and CR plus 2. So on Cn minus r and Cn. Right side is easy. Left side only, you have to take coefficient of x power n minus r. How? N C, because x power should be n minus r. Here also I must have n minus r. So this is coefficient of x power n minus r. That means when I equate right side to left side, I will have the expression 2nc n minus r. Equating coefficient of x power n minus r both the sides. I'm taking coefficient of x power n minus r both the sides. Then I will have 2nc n minus r. But this I have to simplify because this is not there in the option. 2n factorial by n minus r factorial 2n minus n, that is n plus r factorial. This is there in the option. So I can keep the answer like this. This question is little bit difficult to understand, but if we do one or two problems of this kind, I think this question, this type of questions also will become easier. So quickly we will do one more question and we will end the session. Question number 16 we will take. Question number 16 is also this type, that's why I want to do it. 1 plus x whole power n is C0 C1x plus C2x square up to Cn x power n. We have to find what is C0 square, C1 square plus C2 square up to Cn square equal to. I said both the questions are of same type. Here I will tell you without erasing, without doing again and again, so that you will understand better. So first, I will take 1 plus x whole power n as C0, C1x, C2x square and Cn x power n. I can take 1 plus x whole power n again, but this time I will take x plus 1. So what I will have? C0 x power n plus C1 x power n minus 1, C2 x power n minus 2, so on up to C. Now I have to multiply 1 and 2, that is for sure. After multiplying 1 and 2, I have to take coefficient of x power what? For that you see here C0 square. So if I multiply C0 and this, on the right side I will write C0 C0 x power n. I will get C0 square and that is coefficient of x power n. So I have to take coefficient of x power n. If you want, you can check with C1 square. I am multiplying C1 and this. When I multiply C1x and C1x power n minus 1, here also I am getting coefficient of x power n only, C1 square. Like that you check 2 or 3. What about C2 square? Multiply these two C2 terms, C2x square and C2x power n minus 2. Again I am getting coefficient of x power n only. So what I am doing is correct. On right side, the coefficient of x power n already I have verified. So I will write C0 square, C1 square, C2 square up to Cn square. Only thing is left side I have to find coefficient of x power n in 1 plus x whole power n, x plus 1 whole power n. That means I will write 1 plus x whole power n, again 1 plus x whole power n. 1 plus x whole power 2n. So here the power n is 2n. I will take the general term NCR x power r. N is 2n CR. I want coefficient of x power n. That means r I will take as n. So 2n Cn x power n. This is the coefficient of x power n on left side. When I equate left side and right side, I will have C0 square plus C1 square plus C2 square up to Cn square as 2n Cn. And this is there in the option. So I can take this as the answer. So with this, we have completed binomial theorem and the application of binomial theorem. This chapter is completed. So in the next class, we will go to the next chapter. So learn the formulas and concepts about sequences and series. The next chapter is sequences and series. So with this, we will end today's class. See you in the next class.